Welcome back, everyone. I'm Lindsay Brown from Beyond Clean. I don't know about you, but it was the shortest 15-minute break of the day. We're so excited to get back into the action. I'd like to express my sincere gratitude for you for choosing to spend your Friday with all of the speakers and with Brett Norton and myself. You are 100% making our day, and for that, we thank you. As a reminder, in the upper right-hand corner of your screen, you'll find links and documents that you can download that have been provided for you from Beyond Clean, from 3M, and from your speakers. Hey, Brett, the title of this conference, in case anyone missed it, is Prove It, a spotlight on sterile processing quality. How do you think the day has gone so far?
I think it's been pretty incredible. I mean, the number of attendees, live attendees that have logged on and have stuck with us throughout the entire day, especially early, has been phenomenal. We've had some great questions. I'm learning a lot. I'm sure you are. And Indeed. We're already identifying some areas where we can build off of these programs. So yeah, it's been a great day.
It has been, and I've loved seeing how this theme of quality in sterile processing has played out throughout the various educational sessions. Our next speaker is here to keep this day of education rolling. Dr. Paolo Larangiera, sponsored by 3M, is the Sterility Assurance QA Manager at Cardinal Health. He holds a doctoral degree in science and an MBA in quality engineering. Dr. Paolo is a process development and qualification professional for sterilization, having conducted many investigations with biological and chemical indicators. He is well known in this industry as an author, a conference speaker, speaking at international conferences and symposiums. Today, he's going to discuss low temperature sterilization. And I love that we are now moving to low temperature because, as you know, a couple of presentations ago, we focused on steam sterilization. So today we're going to talk about this relatively new technology compared with steam sterilization. And he's going to explain the aspects of H2O2 used in low temp sterilization and what's needed to ensure a load's safe release. So I am really excited to get into it. And without further ado, I'd like to welcome Dr. Paolo Larangiera.
Hello everyone, my name is Paolo Larangiera, and today I'll be presenting the key elements of hydrogen peroxide sterilization equipment. First, I would like to thank the Beyond Clean team and 3M for inviting me to do this presentation today. Important disclaimer points that we need to present, which is related to the content. So the content of this webinar is based on current United States information, including regulations, standards, guidelines, practice as of today. Requirements in other countries may be different, and U.S. guidance may change in the future. Always consult product instructions for use and follow local laws and regulations. This presentation contains an overview of general information and should not be relied upon in isolation to make specific decisions. Now, let's talk about me. I am the Sterility Assurance Manager at Cardinal Health in Miami Lakes. I have over 25 years of experience in sterilization. I founded my validation company 22 years ago, or INCE, and we have offices in Brazil, Portugal, and in the US. I did my PhD on, my PhD thesis was on adopted practice to avoid wet packs in steam sterilization, safety implications and response of biological and chemical indicators. My monograph from my quality engineering MBA was done to demonstrate that refrigerators used to store immunization vaccines require compulsory certification. And today, amid this pandemic that we have, we now understand how important it is to control the temperature of the refrigerators. But at that time, we didn't have, when I did this monography, it was 2007. We didn't have any issues at that time, but at that time, we knew how important it is, and I demonstrated the importance of controlling the temperature of refrigerators. I am a certified sterile processing technician level 1 and 2 by the German Society of CSSST. I am a committee member, AIME committee member for standardization, and I sit on working groups. 1 for EO sterilization, 2 for radiation sterilization, 3 for steam sterilization, 4 which is the one for biological indicator, and 6 for chemical indicators. I have many articles published, and the most recent ones, peer review, are the ones listed here, and one of them is the false positive results of Boyle-Dick type tests using hostels for hostel steam sterilizer with lower come-up ramps, a case study that was published at PLOS ONE. Steam sterilization chemical indicators are not adequate for monitoring real steam sterilizer cycles. That one was published in the PGA journal last year. And the effect of brush motion and rinsing when manually cleaning cannulated medical device. That one was published. I was a co-author and was published at the ARN journal. Okay, now let's look what we are going to see today. So the learning objectives. First one is to comprehend how the sterility assurance level 10 to the minus 6 is achieved using hydrogen peroxide in the vaporized state as a sterilant. Also, we are going to see how to diagnose the principal causes of failed sterilization cycles. So here's one example of a failed cycle. It's when the cycle ends and I take out the BI and I put it in the incubator and I have a positive BI. In other words, I have growth. Then we are going to go over the best monitoring, or determine the best monitoring practices to be adopted when using hydrogen peroxide sterilizers. So let's comprehend how we achieve the sterility assurance level 10 to the minus 6, and this is the goal of all the involved manufacturers in this process, to the instruction for use. So the instruction for use, as I said in the disclaimer, is a document that I need to follow. And we have the instruction for use from the sterilizer manufacturer. We will have the instruction for use of the medical device manufacturer. We will have the instruction for use from the sterile barrier manufacturer, and also the instruction for use of the quality assurance monitors. So each manufacturer is going to test their product to see the performance, and they will write the IFU, the instructions for use, so you can safely use their products. So the IFU is going to tell you if that medical device excuse me, can be used in that sterilizer, can be sterilized in the hydrogen peroxide sterilizer. It's also going to show to you that the sterile barrier that you're using is adequate for hydrogen peroxide sterilization, and that the quality assurance monitors were developed and tested and also approved to be used in hydrogen peroxide sterilization monitoring. So all of them, the 4 of them, know that the hydrogen peroxide variables, the critical variables, are the hydrogen peroxide agent, sterilant, temperature that I need to expose my products, time, the time that I need to expose my medical device to the sterilant, and that the sterilant is delivered or is present in the equipment in the liquid state. So I will need to give energy to this liquid, to this sterilant, so I can move from the liquid state to the gas state. Why do we need to do that? Because the sterilant at the liquid or the standard presentation will have, like the 2% hydrogen peroxide, will need 5 minutes to cause 1 log reduction. If you go all the way to the hydrogen peroxide that we use in the sterilizer, we will need less than 10 seconds to reduce 1 log. So as you can see, hydrogen peroxide is extremely effective in inactivating or in reducing 1 log of my population. The manufacturers know that we have different cycles configurations that achieve the same goal. So we have, for instance, equipment that do not have the plasma phase. So the plasma is used today, and we're going to see later on in this webinar, to remove the hydrogen peroxide from the chamber. And we have, of course, equipment that do have the plasma to remove the hydrogen peroxide after the sterilization phase. So the equipment that do not have plasma, normally they have more injections, hydrogen peroxide injections. So for instance, this example, we have an equipment that will inject 4 times hydrogen peroxide inside of the chamber. And we also have, in this case, equipment that has a plasma at the end of the cycle that has 2 hydrogen peroxide injections. One over here and another over there. So these variations, normally the manufacturers know that they exist and they do test devices with that configuration. So how do we achieve the sterility assurance level using hydrogen peroxide? Sterility assurance level 10 to the minus 6, the SAL. Let's look into the 2 infusions cycle. So here you have the conditioning phase, which is the vacuum phase, and we are going to see a little bit further how to manage this phase, or what is the importance of this phase. And then when it reaches the control level, it's going to inject the hydrogen peroxide, and we're going to have the exposure to that agent. And if you look into this graph, I have here in the dotted red line the Q curve of a saturated steam sterilization. As you can see, the cycle starts at 10 to the 6, and during the whole exposure phase in the steam sterilizer, I am able to achieve mathematically the 10 to the minus 6. Because as you know, BIs are variables for the first 6 log reductions, and then the remaining 6 ones are calculated, right? So for the hydrogen peroxide, which is this green curve, is a little bit different. As I showed to you, the vaporized hydrogen peroxide is extremely effective. So I can have 1 log reduced in less than 10 seconds. So this is what you see here. So once I have 10 seconds, I will go from 10 to the 6th to 10 to the 5th, right? And I keep on going. And as you see, as the hydrogen peroxide degrades inside of the chamber, it reduces its effectiveness. And this curve cannot be well calculated. This is just to demonstrate the difference between them. But I can demonstrate this curve using biological indicators all the way to 10 to the 0. From here on, this is something that I cannot calculate. I do not know what happens. So for hydrogen peroxide, the first 6 log reduction is going to happen in the first infusion. The remaining 6 log reduction is going to occur in the second infusion. So as you see here, you have 1 vacuum and 1 infusion. Then on the second one, I have a vacuum, and after that, I have another infusion. So I will have a 6 log reduction over here, and another 6 log reduction here. In total, I will achieve the 12 log reduction that we need. For the equipment that has 4 infusions, I'm going to have 3 logs in the first, plus 3 logs in the second, plus 3 logs in the third, plus 3 logs in the fourth. So this is just mathematical, but to give an idea and how the hydrogen peroxide controls to achieve the 10 to the minus 6, okay, in comparison to the steam sterilizer. So the manufacturers of medical devices, stereo barriers, and quality assurance monitors do know the situation. So the manufacturer, when he's going to develop his IFU, the equipment is going to be placed in a control lab inside of the manufacturing plant, where they're going to write the IFU and do the testing to make sure that what you have in the IFU is going to happen when the end user follows the IFU. So they expect that the equipment that is going to be delivered to you will perform as it performed in their plant, in their research facility. But unfortunately, this equipment have different installation conditions. And the manufacturer tries to have the best installation for their equipment to perform at their top performance. So they will have the best ambient temperature, they will have the best electricity available. Everything is going to be according to the specification at the best. But when the equipment is installed in a hostel, each hostel will have a different situation. I have seen many variations in installations, and installations that we say, we need to control temperature to have the best performance. And I saw hydrogen peroxide sterilizer installed in ambients that did not have any ambient control temperature and perform just fine. So what happened is, and you have to know that, is that the equipment that you have is identical to the equipment that was tested, but will perform according to the infrastructure that you have in your institution. So when you follow the instruction for use, you have to make sure that you know that there is a difference between your installation, your hostel, and the one that the equipment was tested. Now, a few from the medical device manufacturer. So the medical device manufacturer is going to develop a medical device to prevent or to improve a patient health. So he's going to do a lot of research on that. He's going to develop the product, he's going to develop the manufacturing process, and he's going to control all phases from the manufacturing all the way to the delivery of the product. And also the manufacturer tests their device and create their IFU, but in their research facility, they cannot, even though they might have a SPD as equal as yours, they will not have the volume of work that you have in a hospital. So you're not going to see people running around that needs to get products released and need to be packing and loading the sterilizer. Also, when they do the cleaning, for instance, they will have infrastructure to help them lower into the washer, because they have to repeat this process many times. So they have those support equipment. They will be only washing their products. So it's going to be an easy step to reproduce. And then when they go into the sterilization process, they're only going to sterilize their products. They will not use a common hostel sterilization load. Why? Because it is impossible for me to know what every hostel reprocesses or sterilizes all over the world. Every single institution is going to have a different load. So how can I mimic what happens in a hostel site? It's basically impossible. So what they do the testing with their device only, and they write the IFU using their device only. So it is important for you to know that when they write the IFU, they are writing the IFU and based on the assessment done only on their product. They cannot mimic what you have in your SPD. And let's look into the standards now, because the standards when we have standards and we follow standards, we are going to have a standardized process. So it's going to be easy to reproduce what I have in different institutions. So having a standard and following a standard is a fantastic process. So let's look into steam sterilizer, right? We have standard equipment construction standard. So if a manufacturer follows that standard, they will manufacture an equipment with the same requirements that another manufacturer that follows that standard does. Also, biological indicators. By having a standard for biological indicators, I make sure that every single manufacturer and every single supplier of biological indicator will have the same performance tested on their biological indicators. The same thing applies to chemical indicators. I have from type 1 all the way to type 6, so I have type 1, type 3, type 4, type 5, type 6, being 5 and 6 the most critical ones. I also have a standard or a recommendation, a guidance to construct a PCD. ST79 shows me how to build a PCD. And I have a standard for validation, the Series 17665, which allows me to validate my sterilization process. Now, let's look into the hydrogen peroxide. For the equipment construction, the standard is in development. The biological indicator, the standard is in development. For chemical indicators, I do not have any specification for type 5 or 6. PCD, none. I don't have not even a guideline to build a PCD. And the validation. Well, for the validation, I can use the ISO 14937, and I call it generic, but it's not generic. That standard is the mother of all sterilization validation standards. So I can follow it because it allows me to use it to validate my process, but it's not going to be a specific process validation for hydrogen peroxide. So the validation standard for hydrogen peroxide is still in development. So as you can see, also for this, in the standards, we do not have sufficient standardized documents or documents that we can follow to make sure that our process is identical or follow a criteria for testing, anything like that yet, even though hydrogen peroxide has been around for a few years now, okay? So it's important to have that in mind. So look into what I just said. We do have the IFUs. We need to follow the IFUs, but you need to know that the IFUs do have limits. And those limitations, as you know now, will help you to develop the best procedure for you to sterilize a medical device using hydrogen peroxide in your institution. Now, into failed sterilization cycles, how to diagnose the most common failed cycles that we have. So the hydrogen peroxide sterilizer. So no matter which sterilizer I have, I'm going to load, I'm going to put my medical devices in there, and hydrogen peroxide is going to be injected in the chamber for a period of time, and at the end of the cycle, I should take them out, and they should be in the sterilized condition. They should reach the 10 to the minus 6 SAL. Okay. Okay, so now let's look into one of the most common cycle failures that we see today in the market, which is the presence of liquid. Like I explained to you before, the hydrogen peroxide it is present in the equipment in the liquid phase, in the reservoir. So we will need to give this hydrogen peroxide some energy so it can go from the liquid phase to the gas phase. And one tool to achieve that is to increase the temperature, just like we have with steam sterilization. We have water. You give temperature. You heat up the water, and the water goes from liquid to steam. But for hydrogen peroxide, it does have some limits on temperature, but the most important critical point is that hydrogen peroxide is used for low temperature sterilization, for medical devices that require low temperature sterilization. So how can we give energy so my hydrogen peroxide can go from liquid to gas without increasing that much the temperature? I will create a vacuum inside of the chamber. So here is the ambient pressure. So when you close the door, the equipment is going to do a vacuum, right? So it's going to pull down the vacuum, and as I reduce the vacuum, I will need less temperature to promote the evaporation of my hydrogen peroxide to go from liquid to gas. So once I reach the set point where the change from liquid to gas requires a very small change in temperature, this liquid hydrogen peroxide is going to be injected and in the liquid phase, and is going to vaporize inside of the chamber. So when it vaporizes, any liquid that goes from liquid to gas expands in volume, so you're going to see an increase in pressure. So if I see an increase in pressure, it's because my hydrogen peroxide is changing from liquid to gas, and I have that increase in pressure inside of the chamber, and then I will start my sterilization phase. So I love this graph. This graph was developed or created by Larry and Talapa, and as the perfect graph to explain to you guys what is a cycle failure caused by the presence of liquid. Let's look into this situation. Now, if my chamber or my medical devices, my package have water droplets in there, the equipment is going to start doing the vacuum, and since I have a little bit temperature on the jacket outside of the chamber, so I can promote the evaporation of the hydrogen peroxide, that temperature, when it reaches a point where the liquid in there will vaporize, the water liquid in there will vaporize, what will happen is that the equipment is not going to be able to reach the vacuum level because the liquid in there is going to be vaporizing, and the equipment is not going to be able to achieve or to reach the vacuum level that it needs so the hydrogen peroxide can be injected into the chamber. So I'm going to have a failed cycle because of water inside of the chamber or inside of my package or on my medical device. Okay, so that's one of the causes. Volume, and it does not depend on my load. So if I overload my equipment, I will not reach the sterility assurance level because the volume of sterilant that was required for that additional load was not present because my equipment does not control what I put in there. The equipment cannot see if I have one package or 20. It's the same with these steam sterilizer. The equipment cannot see what I have in there. So if I overload my equipment, I will not have sufficient sterilant present during the cycle. Now, to another cause of failures, loading configuration. If I overload, as I mentioned before, if I use a stereo barrier that has not been validated to be used in hydrogen peroxide and then it absorbs my hydrogen peroxide, for instance, or if I use a medical device that has not been tested nor validated to be used in hydrogen peroxide, I do not know what is going to happen during the sterilization cycle with that medical device. Also, I have to be careful with the materials that are used or that are placed inside of the chamber that may have an inadvertent reaction to the hydrogen peroxide, causing the degradation of the hydrogen peroxide before the end of the exposure. So the loading failure will cause a failed sterilization cycle. We have to keep in mind that our sterilization process must achieve 10 to the minus 6. In other words, must achieve a SAL of 10 to the minus 6. And as I explained to you at the beginning, the first part, the first set of hydrogen peroxide injections done here for this no plasma equipment, or the first injection of hydrogen peroxide for this equipment with plasma, will are developed or dimensioned to achieve a 6 log reduction. And the second set of injections, or the second injection of this equipment, is to achieve the additional 6. And this is what I need to achieve 10 to the minus 6. Now, if I have an overloading error, or if I have I don't use a correct medical device or sterile barrier, what is going to happen? The 10 to the 0, or the first 6 log reduction, is going to occur much later in the cycle. So instead of being here, it's going to occur over here. So, and the same with the 2 injection cycle. Instead of happening here, the 6 log reduction is going to happen here, where I have the blue line here. So the second part of the cycle is much smaller, because as I showed to you, the volume of hydrogen peroxide is the same. It doesn't matter the load or the medical device or what I use inside of the chamber. So the second part, which was developed to achieve the additional 6 log, is not going to give us that additional 6 logs. It's going to give us, let's say, 2 additional logs. So we might have cycles in situations like this with a BI that shows a negative result, in other words, no growth, but we did not achieve the 10 to the minus 6, the required 10 to the minus 6. So the overkill requirement will not be met. Okay? Now, after the sterilization, the aeration phase. So the aeration phase is to remove the hydrogen peroxide. The hydrogen peroxide can be removed basically in 2 ways. One, in the equipment that does not have a plasma. So here, at the end of the cycle, you will go, everything that you have in the chamber will go through a catalytic device that will break the hydrogen peroxide. Or, if the equipment has a plasma, I will increase the voltage or the frequency, creating or giving more energy to reach the plasma phase, and then the plasma phase will break the molecule, like 2 molecules of hydrogen peroxide, into 2 molecules of water and 1 of oxygen. So the aeration phase is extremely important, so I can safely open the equipment and not be exposed to a contaminant, a hazard product, which is hydrogen peroxide, is hazard for our health. So we need to make sure that the aeration is done correctly. Now, knowing that the IFU limitations and the critical points that cause failed cycles, how are we going to monitor correctly our hydrogen peroxide sterilization cycles? So, into steam. So, because steam is something that we use for ages, and we have many controls. We have the water that is used to produce steam. We have we control the water. We have leak tests in the equipment that is going to test the equipment if there is no leak. Because if I have a leak, I'm going to have air in the chamber, and I cannot do that. I have Boyd test that it's a daily test device that is going to challenge my equipment daily to make sure that my equipment removes the air and the steam penetrates the density. And I also have those Boyd in the electronic configuration, which will monitor my steam cycle daily. The equipment has controls that with values that I can challenge in the validation. So I have temperature, control, and pressure that I can, in the validation following 17665, I can put thermocouples inside of my containers, and I can compare the temperature from the drain with the temperature inside of my containers. I also have a detailed printout with every phase of the cycle that I can compare with the validated cycle that I did. I have biological indicators that are built and tested according to standards. I have type 5 indicators that are also built and tested according to standards. And I also have a PCD. So for us to release a load in using steam sterilization, we have many devices and we take many actions to make sure that we are releasing the load safely. Now, let's look into the hydrogen. What do we have today? Well, for the hydrogen peroxide equipment, we have the printout. Unfortunately, the printout does not have that much data. They're improving, but how can we validate? We do not have the validation to compare that, right? But we have the printout. We have type 4 chemical indicators. We have biological indicators. But, do I test the vacuum? No. Do I test the gas concentration? No. Do I have a PCD? No. Do I have equipment qualification to make sure the printout is aligned with what happened inside of my load? No. Do I have chemical indicators type 5 and 6? No. Do I have any electronic test system to challenge my device? No. So with that in mind, as you can see here, we don't have many monitoring devices and actions to monitor daily my sterilization cycle, my hydrogen peroxide sterilization cycle. So I have to use what I have available today, which is biological indicators, chemical indicators, and the printout to create actions to monitor correctly my sterilization cycle and the products that were sterilizing hydrogen peroxide. So let's look into the hydrogen peroxide variables and how am I going to monitor them. So as I told you, the hydrogen peroxide, we need the agent to convert the liquid to gas. I will add temperature and I will have in vacuum, and then I'm going to expose my medical device to this hydrogen peroxide in the vaporized state for a certain period of time. And as I showed to you, the cycle is divided in two parts. The first phase is for the second, the first part is for the first 6 log reductions, and the second part is for the second 6 log reductions. The same thing happens with the 4 injection equipment. So if you look into the control, do I control the hydrogen peroxide or the loading? Does the equipment changes, like in steam, for instance? If in steam, if I overload, it's going to use more steam. So the emission steam is something that is continuous and it depends on the amount of product that I have in there because of the condensation. So the agent, the stirlant, is always being sent into the chamber as my load varies. For hydrogen peroxide, I do not have that. So if I have a situation of a lower loading or a higher loading, I do not know if the sterilization or the SIL of 10 to the minus 6 was achieved. And if I cannot have that from the printout, which is the parametric release, which we normally see people tending doing it, they see the printout, the equipment reached the parameters, and it's going to say the cycle is perfect. Can I release it? No, we cannot release it. We cannot adopt parametric release because the equipment cannot control or cannot know if there was an impact caused by the overloading or the loading configuration that might not allow the equipment to achieve the 10 to the minus 6. So the parametric release cannot be a solution for hydrogen peroxide. What do we have to do? Well, we have BIs, and as you know, BI, and I showed it to you, that BI is only viable to the 10 to the 0. In other words, the spores are only there during the 6 logs reduction. So during the time and hydrogen peroxide that is they are exposed, we might think that the BIs are not sufficient to be used to monitor my cycle. But this is the most important part of it. If the sterilization cycle is overloaded or I use the wrong loading parameter, the hydrogen peroxide quality or concentration, or I will have a degradation of the hydrogen peroxide. And by having that degradation, even though I have the right exposure time, because of the degradation of the hydrogen peroxide, my BI will show a positive result at the end of a approved cycle. So I will have the printout showing a approved cycle, but my BI is going to show a positive result. And why is that? Because I either overloaded the equipment, which caused a degradation of my hydrogen peroxide, or I didn't have sufficient hydrogen peroxide for all the projects in there, or I used devices or barriers that degraded my hydrogen peroxide. So that's why BIs, even though they do not measure the 12 log reduction, but they do measure the presence of hydrogen peroxide. And if we have hydrogen peroxide in a level that will sterilize, they will have negative results. So that's why it is important to use hydrogen peroxide to monitor my cycle. I'm sorry, to use biological indicators to monitor my hydrogen peroxide cycles. So now let's look into CIs, chemical indicators. Chemical indicators are fantastic because we can use them with the medical device. The biological indicator I cannot put in the medical device because I have to open the sterile barrier to read the biological indicator. But the chemical indicator, I can see the result without opening the barrier also. And I can place it in the device. So if I have a chemical indicator with my medical device, this chemical indicator will monitor my cycle and will monitor if the stimulant was present close to the medical device during the exposure phase. So if I have the hydrogen peroxide in volume and in duration close to my medical device, I will have a approved chemical indicator. So for hydrogen peroxide sterilizer loaded release, I should have looked into the characteristics of these devices, a CI with all my medical devices. I would add a CI and a biological indicator in a pouch to be placed inside of the chamber. And if I have this pouch in the most distal part of my sterilizer from the injection of the hydrogen peroxide, I can measure if the hydrogen peroxide was present throughout the chamber during the sterilization. Combine both BIs and CIs, combined if the printout are adequate or are the correct actions for me to release a load. So I need to have BIs and CIs for every load monitoring hydrogen peroxide. So the physical indicator is going to show to me that the IFU that I'm following is the correct one. I'm going to have the program, I'm going to look into the IFU, and if that program is the correct one for my medical device. The physical indicator also is going to show to me that the equipment process was run according to specification. The biological indicator is going to show to me that the sterilant concentration was present for a sufficient time and temperature to inactivate the spores. The chemical indicator with the medical device is going to show to me that the sterilant for that period of time was present where my medical device was placed inside of the chamber. And if I have my biological indicator inside a pouch in the most distal point or the worst location inside of the chamber, I will monitor the sterilization conditions where we're monitored to see if the sterilization conditions were present throughout the chamber during the exposure phase. Okay? So now let's go for the fun part. Let's go for our... So thank you very much. I know now we are going to go to our Q&A, which is online after this presentation. Thank you so much for your attention. Take care.
All right, wonderful. Thank you so much for that presentation and for joining us live for the question and answer session. We did get a couple of great questions that came through. If anyone else has some burning questions on H2O2 sterilization, feel free to enter them in the lower left-hand corner in your Q&A engagement tool, and we'll get to as many as we can. Dr. Paulo, thank you. Again, for sharing that information. The first question that came through, should there be a BI in every load in our 100X SteriRad machine? We do it once a day right now.
Okay, as I showed in my presentation, the importance of having the BI and correctly placing the BI inside of the chamber will improve how I address the approved cycle. Because today, by only doing once per day, in other words, only monitoring one cycle per day, I can tell you that in that cycle, the 2 infusions or the 4 infusions, doesn't matter, but the sterilization cycle, that cycle works. But it's different than what we see, for instance, in steam sterilizer, that we do the Boydic once a day, and we know that preconditioning and the steam penetration is good, that everything should work during the day. For hydrogen peroxide, that's not sufficient because the BI response will vary according to the load, as I showed during the presentation. So since we do not have a sterilant volume control per load assembly, in other words, I'm going to have the same volume of sterilants independent if I'm stirring 1 pouch or 20 packs, I should have a BI in every single load at the most distal point from the entrance of the sterilant.
All right, wonderful. This next question that came through is, what is the limiting factor with lumened instruments that restrict which can use this modality?
Okay, as you saw, for us to have the hydrogen peroxide vaporized, we need to reach deep vacuum. So it's not a matter of restriction, it's a matter of following the IFU from the manufacturer. Keep in mind that the manufacturer of the medical device, of the lumen device, probably only tested his device. So if we are going to sterilize the lumen device with other products, we might not achieve the ideal air removal or air removal to penetrate, to have the hydrogen peroxide penetrate inside of the lumen. And also we might have some water residue in there. So depending on the lumen device, I would recommend to have a very small load until you have better tools to address the variation of loads that you have in a hospital setting.
All right. This next question, also a great one. Are there any special considerations for tray or instrument design for H2O2 versus steam sterilization?
Well, those products have to be developed and tested for that specific sterilant. There are some trays that are built that can be used in both systems. It is important that the manufacturer of those trays, that the manufacturer of those trays do the testing and write the IFU, the instruction for use accordingly, so you can safely use that stereo barrier or that tray in both systems. But that's the idea, right? I don't want to have one for steam and then another set for hydrogen peroxide. But we need to make sure that it does meet the requirements or the sterilization requirements for both sterilization methods.
That would make everyone's life significantly easier if that was the case. Yes, and if that stays the case. This next question is about material compatibility. It says, I work for a hospital that says we can't use peel packs for hydrogen peroxide. So is there a certain way we should be using them? Do you have any advice on compatibility?
Compatibility to the peel packs inside the hydrogen peroxide? It's sterile barrier, right? We need to validate. Even though the manufacturer is going to tell you that they tested, we need to follow 11607 as a sterile barrier validation to make sure that that sterile barrier is going to support the vacuum and is going to allow the penetration of the sterilants. So we need to have a test procedure to make sure that pouch can be correctly used, safely used in hydrogen peroxide.
Okay, great. This is a very interesting question as well. It says, are you saying, and I think this came in right as you were answering the question about what the limiting factors might be for lumen instrumentation in hydrogen peroxide sterilization. And this says, are you saying that hydrogen peroxide is somewhat unstable?
No, it's not. It's not a matter of stability. It's a matter of process development. I do believe hydrogen peroxide is a fantastic technology for low temperature sterilization. It's important for us to know the limitations. We cannot trust only the equipment showing that the cycle was completed, was fully completed. It is satisfactory. I need to make sure that inside, that adding my medical device, that sterilization was reached. That's what I'm saying. I don't have anything against the technology. I love it. I have been studying and working with it since Carbon Wagner did the first webinar or for the first training for me back in the ages in 2000. Well, doesn't matter. So it is important. It is a great technology. So the only thing that I want to keep in mind is that we need to understand the limitations and create a procedure knowing those limitations.
All right, very good. This next question says, what is the difference between H2O2 and vaporized H2O2?
Okay, so if you go into the literature, if you look into peer-reviewed articles, you're going to see that some authors and some researchers, they reference differently. They call it either plasma, gas plasma sterilization, vaporized hydrogen peroxide, and depending on the manufacturer, they will defend the technology according to the technology that they use. As I showed in the presentation, we do not have a standard, right? A construction standard for those equipment yet. It's being developed. So we have to rely on the manufacturers. To me, there isn't any difference between vaporized or gamma. It's just a matter of how the cycle is controlled. As I showed to you, the hydrogen peroxide is at the equipment, at the reservoir or in the ampoule in the liquid phase. And during the cycle, the liquid hydrogen peroxide is going to move from the liquid phase to the gas phase. So I don't know if you want to call it vaporized or if you want to call it gas, or it's a matter of how the researcher from a specific manufacturer is referencing that technology. But at the end of the day, they are identical. And the plasma part, the plasma is related to the aeration, the removal of the hydrogen peroxide at the last infusion or after each infusion. So if I use plasma to remove the hydrogen peroxide, the plasma occurs during a cycle or a controlled phase of the cycle. So we have some authors that say that the plasma can be responsible for 1 log reduction. So can we call it a plasma sterilization, plasma hydrogen peroxide sterilization? Because of that, we might. But at the end of the day, all of them are identical. All of them use hydrogen peroxide in the liquid state as the initial sterilant, and during the cycle, they control it. Every manufacturer has their way of controlling how this sterilant is going to be present inside the chamber.
Wonderful clarification. Thank you for providing that. This next question says, is there a specific reason why implants don't include H2O2 recommendation?
Okay, so this is going to be on the manufacturer of the implant, right? Normally, when the manufacturer of the medical device is testing the reprocessing sterilization technology that is going to be available at the hospital site, they try to use the most common one. There is no restrictions, even though there are some articles, especially from Japan, saying the hydrogen peroxide is hazardous. But as for EO or for any low temperature sterilization that we have, we are using a chemical as a sterilant. And we have to know, once again, the limitations of that chemical so we can address it correctly, how we're going to condition the cycle, how we're going to remove the residuals. So I would say that not having the hydrogen peroxide as an sterilant for some medical devices is just because of a specific characteristics of the medical device that manufacturers knows about it, but there's no restriction as a general rule.
Okay, great. This next question says, can you explain the differences with sterilization biological indicators that have shorter read times for either steam or low temperature? Are they approved to run on all cycles or just certain ones? Is there anything concerning about those shorter read times?
Okay, so I don't know. I guess you guys had a webinar on biological indicators. I'm sorry I didn't watch all of them today, but this is how it works. Biological indicators, the spores, right? The readout. The real readout is when I see the culture media changing color or being turbid, right? So it's a 7-day incubation. Anything besides that is called accelerated incubation. So this accelerated incubation can be a pH changing in the water, which will change the color from purple to yellow, for instance, which would give you a readout in 48 hours instead of 7 days. Or I can read a enzymatic activity on the spores, on the side of on the spores present in the BI. And I can read that activity, the enzymatic activity or presence or reaction to light in a shorter period of time. So I can read it. Now we have technology in 10 minutes, 30 minutes. So I can read it out really fast. So the important part is, it is a spore, right? If I'm reading in an accelerated method, it's validated. There are peer-reviewed articles on that. It is valid, and I can rely on that as being even better than the 7 days interpretation. What I have to be careful is, depending on the studies, I have a different way to calculate the accelerated reading that I do in the BI. That's why I have a little bit difference between the BIs that are used, that are super rapid BIs for steam, and the ones that are for hydrogen peroxide. They look the same, they use the same spore, but they have different readouts. And this is because of how the spores are exposed to the stimulants, how they will react in the enzymatic activity, and how it's going to be detected in the incubator. So at the end of the day, what makes the change is the incubator. The incubator is the one that is doing the reading. The BI, the spore, the poor thing there is not doing anything. It's just going to be dead or alive.
All right. Again, great clarification. Dr. Paulo, we thank you for your time today. We're coming up on the end of the time for this session, and I want to thank you for sharing your expertise. I love hearing from folks who have studied a specific subject for years. You just have such an in-depth perspective, and I appreciate your willingness to share that with us, with our audience today.
Thank you very much for having me. It was a great opportunity, and I enjoyed it a lot. And I wish that success for the remaining of the presentation that you guys are going to have today. And I hope to see you in a future presentations.
Agreed. We do as well. And similar to the previous transportation presentation, we could also spend an entire conference talking about H2O2, low temperature sterilization. So perhaps something to look forward to. And if that ends up coming to fruition, we will certainly have you back for that. If anyone has
very interesting breaks, so people don't get tired. If you're going to talk the whole day on sterilization, we're going to plan some breaks so people don't get tired. So.
We'll have to get creative when it comes to the breaks for sure. If anyone has additional questions for Dr. Paulo, you can feel free to reach out to him. His contact information is right in that speaker bio tool on the right-hand side of your screen. Thank you so much to his sponsor today, 3M, for not only making this whole event possible, but also for contributing such incredible speakers. We appreciate that. Again, there will be a 15-minute break between sessions. If you're wondering about your CE credit after the last session of the day, you will get a link to a survey. You can fill out that conference survey and download your CE certificate right away. No need to wait. And all of these conference sessions are available on demand about an hour after each session ends. So you can come back to these sessions, you can share them with your peers and your colleagues, and you can reference them in the future when additional questions arise on the subject matter. Everyone, we will see you again in a short while. Dr. Paulo, thanks again. I hope you enjoy the rest of your day as well.
Thank you very much.
Thank you.
Take care, everyone.